Hello everybody, this is Rudra Pradhan here and welcome to BMD lecture series, and today we will continue the concept inferential analytics, and in fact in the last couple of lectures we have already discussed this issue, and it is the case where we are dealing with the business problems relating to multiple sample case. And in the last couple of lectures we have solved problems by using Z statistic, T statistic and F statistic, and today we will continue the similar kind of problems by using F statistics, and typically we will focus on the concept called as ANOVA, that is the analysis of variance, and today we will continue the ANOVA by connecting one way structures, two way structures and three way structure, and finally it will continue the concept called as MANOVA, that is multivariate analysis of variance. And the concept is so interesting that if you have a multiple sample case, so how we can actually check the kind of within the difference and between the difference and with the different kind of layers or different kind of factors. In typical it is a kind of multivariate kind of structures. So, let us see how is this particular concept, and then we will discuss. So, this is what the kind of discussion today, and the highlights of this discussion will be the ANOVA models, and followed by factors, then designs, and we will connect with the concept that is ANOVA, and we will dealing with problems, categorical data analysis, and finally the goodness of fit. So, in the last couple of lectures we have already discussed the concept, typically the F statistic issue, and in a kind of structure multiple sample cases, and here. So, we will start with the same concept, but with a kind of different structure altogether, and let us start with a concept called as models. So, since it is a kind of multiple sample case or multivariate kind of structures. So, there is a kind of typically you will find the relationships, and that relationship is a kind of complex kind of structure. So, obviously, since there are a couple of variables and that to multiple sample case. So, you cannot actually simply analyze the particular structure and get some kind of inference as per the business requirement. So, that is why we need to develop a models, and through the models we have to analyze the particular problem, and then we will get some kind of inference. So, now as we have already discussed, typically statistical model is a set of equations and assumptions that capture the essential features of real world situations, and the structure is we start with a kind of concept called as one factor ANOVA model, and the model will be like this xij equal to mu I plus epsilon ij, and so mu is the kind of concept called as sample means, and then epsilon ij is the error associated with the jth member of the ith populations, and we are assuming that these errors are normally distributed with the mean 0 and unit variance, that is the sigma square, and in the other side a factor is a set of populations or kind of treatments of a single kind. For examples, we have actually one way structure, two way structure, three way structure, and in the case of one way structures, that is called as one we have a typical factor models based on examples like hotels, type of aeroplanes, and the kinds of colors in a particular product, and two factors models based on business firm and the kind of site location, and three factors models can be like color, shape and size of a particular service or kind of product, and the typical analysis will be on the basis of the concept called as fixed effect models and random effect models. In fact, this particular ANOVA is well connected with a concept called as penal data, and in the last couple of lectures we have already discussed this data issue, and then data can be actually connected or used in a kind of business environment or business analytics in the form of time series, cross sectional and panel. So, ANOVA is a kind of cluster like panel data structure altogether. So, we have a separate lectures about the panel data modeling, but in the meantime we will analyze the similar kind of problems in a kind of structure called as of factor models, that is one way factor model, two way factor model and three way factor model depending upon the kind of structure of the business problem. And here we have actually typically two different models which you can connect with this particular situations. So, the first one is called as a fixed effect model and the second one is called as a random effect model. In the fixed effect model, the levels of the factor under study are fixed, and in the case of random effect models, the level of factors under this study are randomly chosen from an entire populations, and that is the treatments, and the inference is valid for the entire populations for this particular study or analysis. And the third component is with respect to experimental design, and basically ANOVA can be connected with the design of experiments, that is typically called as DOE. And here a completely randomized design is one in which the elements are assigned to treatments completely at a random basis, and that is any element chosen from the for the study has an equal chance of being assigned to any treatment. And in the case of block designs, elements are assigned to treatments after first being collected into homogeneous groups. So, in a completely randomized block designs, all members of each block, that is the homogeneous groups, are randomly assigned to the treatment labels. And in the case of repeated measures designs, each member of each block is assigned to all treatment labels. And in the case of two-way analysis of ANOVA, typically the effect is with respect to two factors or it is with respect to two treatments. So, that means typically actually we have a concept one factor model, two factor model, three factor model. In the case of one factor model, so we have a one factor, then the kind of different sample variation will be there, and then in the two factor models we have actually two different factor through which the investigations can be, you can say, jointly investigated. Then in the case of three factor models, we have a three factors through which these simultaneous interaction can be investigated. So, now in the case of two factor models, so we have actually main effects and then the kind of interactive effect. So, for instance, if there are two factors A and B, then the main effect will be effect A and effect B, and the interactive effect will be A B together. So, that means it is a intersection between A and B. So, in the kind of problems, multivariate problem is with two factors. So, we will find actually kind of cross correlation or kind of concept that need to be connected while you are investing the kind of interrelationship among the variables. So, typically in the two-way ANOVA case, we have a three different effects. So, the main effects, that is with respect to two factors and their interactions. So, let us see how is this particular structure, and this is how the two-way ANOVA model, and xijk is the kind of a total effect, and that is connected with mu, that is the population mean, and subject to alpha I plus beta j and plus alpha beta I j and epsilon I j k. So, that means mu is the overall mean and alpha is the effect of level I for factor A, and beta is the effect of level j for factor V, and alpha beta is nothing but the interactive effect, and the epsilon I j k is the kind of error associated with this kind of link, because we are actually structuring with respect to two different factors. So, obviously, there is a kind of cross correlation, and then you need to have a interactive effect and along with the error terms, and here the error terms are distributed normally and with the assumption that zero mean and again unit variance with respect to I, j and k. And typically two ANOVA problem is like this. So, let us take a case factor A So, we have a information here, the kind of let us say this is a kind of problem, say resort, and then factor B attributes. So, in this particular problems, we have actually 4 attributes: friendship, sports, culture and excitement, and then we have a 5 different resorts. And again, so we like to check how is the kind of rating, a rating of a particular hotels, and with respect to these 4 attributes. So, it is a kind of hotel business. You will find the customers, and they like to enter and they like to leave, and during these times they we usually collect the informations, and that information will be very helpful to analyze the problem, and then you can actually use for some kind of improvement or some kind of management requirement. So, so in this case, so the rating are recorded for different hotels with respect to different attributes, and the usual typical structure of the effects will be like this. So, it is a kind of multiple kind of plotting, and with respect to rating, and that too with respect to 5 different resorts. So, the kind of interactions. So, this is the graphically visualization about this particular problem, and we need actually the kind of quantification, the total effect or to total quantifications, how they are interactive each other, so far as the particular problem is concerned, and accordingly. So, we will see how is the particular structure, then we will discuss. So, what we have already discussed that in the 2A process of ANOVA. So, we have actually 3 effects. So, the since it is 2 factors. So, the main 2 effects are factor A and factor B, then finally, the interactive A B. So, that is connected with the alpha I, beta j and alpha beta I j, right. So, now accordingly, so the kind of null hypothesis will be alpha I equal to 0 for all I. Again the counterpart alternative hypothesis will be not all alpha I are equal to 0, and similarly we can set for B j. So, this is for second factors, and then finally, there is a interactive effect. So, that means alpha beta j I j equal to 0 means we assume that there is no interactions, but again so the alternative will be, so at least one interaction is there. So, likewise this is how these typical structures, and that need to be tested with this particular concept, right. So, let us see how is this particular structure. So, since it is a kind of ANOVA, that is the analysis of variance. So, we like to check this particular effect with respect to variance, because it is a variance statistics, and as a result the typical model is here. This is what the typical models. So, and it has 2 parts, and total SST means total sum of square, that is the total variance, and then it is divided into 2 parts, that is the error part and the kind of sum square totals, the kind of factors. So, as a result, so the sum square total will be, so sum square total variance from factor A, variance from the factor B, that is actually main effect, and then this is the interactive effect, sum square through the interactions, right, and then this is the error component. So, the procedure of getting this kind of outcomes like this, which we have already discussed in the previous lectures in the case of one way ANOVA. So, now with the help of this data, so you have to find out the variance for a factor A, factor B, and for the kind of interactions, and then the error component, and if you add all together, then you will get the sum square totals, or else sum square totals if you can calculate, and SSA and SSB and SSB, then by doing some kind of simplifications you can get the sum square errors. But typically, so our requirement is what is SSA, SSB, SSAB and SSE. So, these are the items through which you have to check the effect, that is the main effect, and then the kind of interactive effect. Okay. So, since we have already gone through this ANOVA, that is one way ANOVA. In this case, it is the similar kind of structure, and in this case, So, this is for factor A, this is factor B, and this is interactive effect, and then the errors. Since we are dealing with two factors and the interactions, by default some error will be will be there in the systems. Okay. So, as a result, so for factor A, so the sum will be sum squares for factor A, SSA, and for factor B, so it is SSB, and then interactive it is sum squares of interactive AB. And for factor A, so the degree of freedom is a minus 1, because we are allowing the factor samples for up to A. So, that is the size of the samples, and by default the degree of freedom will be a minus 1, and similarly for factor B it will be b minus 1, and the interactive effect will be a minus 1 into b minus 1, and the error component accordingly will be a b into n minus 1, and the total for the total, that is the sum square total. So, this is the combined samples, that is a b n, and that too the degree of freedom will be a b n minus 1s, and we typically get to know. So, what is the mean square of factor A, mean square of factor B, and mean square of interactive. So, this is nothing but actually sum square of factor A divided by the degree of freedom, and it is followed by factor B, and also it is followed by interactive effect. So, accordingly we have actually 3 different F statistics for 2A ANOVA. One is for factor A, one is for factor B, and one is for interactive effects. So, we like to know with respect to the total variations which factor is more effective, and then whether the interactive effect is statistically significant or not. And in order to justify this, so we have to take in live examples. So, let us take these examples, and then we will see how is the kind of structure. So, this is the kind of with a particular samples, and that too with two kind of structures, location and artist, and with this with kind of data analysis. So, we have a SSA here, and that too okay. So, that too SSA here and SSB here, and then this interactive effect, and then the SSE, that is the sum square errors. And if you add all these 3 4, so you will get actually the total effect, that is called as sum square totals, and the corresponding degree of freedom is 2, 2, and then 4, and that is for error 81s, and the total samples for this particular data is nothing but 89, and that means 90, and then this degree of freedom will be 89 for the SST. And accordingly, so this will be mean square for factor A, this is mean square for factor B, and this is mean square for interactive. And then corresponding to this is the F calculated for factor F, F calculated for factor B, and F calculated for interactions. And then so corresponding to this degree of freedom, and then you will go to the F criticals and check whether this F calculated will overtake the F critical depending upon the kind of alpha which you have actually fixed here at a 1% and 5%. So, that means typically actually even if you do not fix actually alpha. So, first you have the calculated value depending upon the sample information and the problem, and then you have actually a critical value depending upon the kind of structure which you can actually fix or allow. For instance, you can fix alpha equal to 1%, you can fix alpha equal to 5%, you can fix alpha equal to 10%. So, accordingly, so you can get 3 critical critical values. So, now this calculated value can be compared with 1%, 5% and 10%. Typically, if it is actually statistically significant at 1%, that is the highest weightage you can give into this kind of difference, followed by 5% and 10%. Okay. So, in this case, let us see what is happening. So, the critical value will be 4.88, and then it is actually 2.48. So, in the both the cases actually, and the calculated value is overtaking the tabulated value. So, as a result you are rejecting the true null hypothesis, but in the case of interactive effect, it is actually coming less, that is less than 2 critical value. So, we cannot actually reject in this case. So, that means in this particular process, so the main effects are statistically significant, while the interactive effect is not statistically significant. So, that is how the kind of structure, and then accordingly we will discuss this particular process, and this is how the significance which we have already highlighted, but it is a graphical kind of plotting, and this is the rejected zone, and this is the rejected zones, and this is also rejected zones. So, in the case of main effects, it is coming statistically significant. These are the two main effects, and this is what the interactive effect, and which is actually a lesser to critical value. As a result, we are not in a position to reject here, but in this case your calculated value is overtaking the critical value, and hence we are actually rejecting as a result. So, the locational effect is there and artist effect is there, but the interactive between the location and artist is, which is not actually statistically significant here. And this is actually the kind of Excel template while analyzing to a ANOVA, and I will discuss these problems through Excel sheet. Let me first complete this one, then I will go to this particular Excel view. And in this case this is actually 3-factor model, and this is extension of again ANOVA. And in this case we have actually 3 factors, and the 3 factors is actually A, B and C, and in the case of 2 factors we have a main effects A and V, and the interactive effect will be A V. But when there are actually 3 factors or 4 factors and 5 factors like this, so the interactive effect will be continue in a kind of complex process. And typically for these 3 factors models, so we have a 3 main effects, that is SSA, SSB and SSC, that is some square of factor A, some square of factor B and some square of factor C. Then by default, so there are 3 interactive effect. So, between AB, SC and BC, and then finally the combined interactive effect, which is nothing but actually ABC. So, as a result, some square AB, some square AC, some square BC and some square ABC. And finally, when you are dealing with more factors, and by default there will be error component, and that will be represented by sum square errors. In fact, sum square error was also there in the case of 2 ANOVA, and in that case we have actually two main effect and 1 interactive effect. Here we have actually 3 main effects A, B, C, and then 3 interactive effect A, B, A, C, B, C, and then combined effect, that is the interactive between A, B and C. So, the corresponding the degree of freedom will be A minus 1, B minus 1, C minus 1, and like the previous one, it is A minus 1 into B minus 1, A minus 1 into C minus 1, B 1 minus 1 to C minus 1, and then A minus 1, B minus 1, C minus 1, that is for joint effect of A, B, C. And finally, this is for error sum squares, and this is for sum square totals, and accordingly you can find out mean square for factor A, factor B and factor C, and this is what the interactive effect between A, B, interactive between AC and interactive effect between BC, and this is the interactive effect combined ABC. And accordingly, we have actually in the case of 3 factor models, so these are the 3 main factors, and then these are the 3 actually kind of interactive factors. So, altogether, so we have actually 7 different test statistics which you like to report in the case of 3 factor models. So, while in the case of 2 factor models we have 2 main effects and then 1 is the interactive effect. Okay, so, let us see here. So, connecting to this, so this is actually 3 factor model situation, and accordingly we can connect with 4 factor model, 5 factor model. So, when we add one after another layers, then the degree of complexity and the kind of effect will be more and more. So, which we have already seen from the movement from 1 to 2 and 2 to 3 like this. So, when we will add one after another factors, then the combined effect or the kind of interactive effect will be complex, and then it will be very in fact it will be very interesting, and also it will be through complex process we have to investigate, and then we can analyze the process. In fact, for more factors and more kind of typical samples, so manually it is not possible. Through software we have to actually you can deal with the kind of analysis, then finally we will check the kind of variance. And in the case of block designs, so let's see what is actually block. A block is a homogeneous set of subjects grouped to minimize within group differences. And in fact, we have what we have already mentioned, the completely randomized design in one in which the elements are assigned to treatments completely at random. And in fact, we have already mentioned all these things, completely random designs and block designs. So, let me take the kind of model part of this block designs. And like the previous factor models, so the block design model usually represented like this. So the main effect, which is actually mu alpha I beta g summation alpha I j, and then so it is followed by the alpha component, and that is the effect of label 1, and beta j it is effect of block j, and mi is the overall mean. And like the kind of factor model, so this is the error term, and again so we are assuming that the error term will be normally distributed with the mean 0 and unit variance, right, and that is the homogeneous variance. So let us see how is the particular case here, and this is how the typical problems, and it is like kind of typically ANOVA structures, but here the items are just like different, because it is a kind of block design problem. So as a result, so compared to the previous one, so the first effect will be blocks, then treatments. Okay. So this will be blocks, treatments, and the error component, and then finally total. So again similarly sum square for blocks, and sum square for treatments, and then sum square for errors, and if you combine all these, then you will get total sum of squares, and corresponding to this is actually block wise is nothing but actually the kind of column variations, and this is the row variations. So typically, so the degree of freedom will be n minus 1 and r minus 1, and then finally, so for errors it will be n minus 1 into r minus 1. And like the ANOVA, so we will find out the mean square for blocks, mean square for treatments, and then mean square for errors. And in this case, we are interested about the block effect and the treatment effect, and accordingly we have a 2F statistics, and with a particular sample problems. So we have calculated here actually sum of square for the blocks, sum of square for the treatments, and sum of square of the error. The first and check is actually these three should actually close to total sum square, and the corresponding degree of freedom is reported here, and again simplification you will find mean square for blocks and mean square for treatment, and then this is what the calculated value, and again fixing alpha, and then reporting the critical value for f, and you can check the value. So since actually this value is lesser to this particular value, so we are not in a position to reject the null hypothesis, but in this case we are actually rejecting the null, because it is overtaking the kind of critical value. Okay. So this is actually again Excel template how we have to do the kind of analysis, and in fact before we go to this particular process, let me highlight the kind of examples how you can go to the analysis and solve the problems. So this is actually a spreadsheet, and we have actually couple of samples here, and then we like to test through simply start with simple f, then we will go for one way ANOVA, two way ANOVA, and three way ANOVA like this, and then since actually okay, this is okay. So go to the data analysis package, and in fact you will find here you will find here these are the tests. So we need to test first f statistics. So this is actually f statistic for two sample variance, let us say. Okay. So this is with respect to the previous class discussion. So when we will go for means it is actually multi sample case. So the multi sample case means at least you must have actually two different samples, and then we must have some sample points to test the kind of variance. So now accordingly you have to specify here the first sample case, and then you have to specify the second sample case, and like t and z. So you have to just put okay. So you will find this is how the f distribution, this is the f distribution values, and this is f critical, and then finally this is f critical, and this is what the f calculated on the basis of these samples, and these are all mean reporting of these two variables and variance of these two variables. These are all counts, that is sample observation, and f reported is this much, and the degree of freedom is this much, that is actually n minus 1, and then finally with comparison, since this f calculator is overtaking the f critical, so it is statistically significant, right. So, this is what simple f statistic, through f statistic you have to analyze this problem. That means, there is a significant difference between these two samples, and then accordingly the management decision will be taken into consideration. Now, again you go to the data analysis, same structures, we will analyze this problem through ANOVA, and you see here ANOVA single factor models, which we have already highlighted. Then you just actually highlight again. So, the entire sample you just highlight, and then you give the kind of okay. So, this is how the usual representation of this is what actually the output, and we are actually having between the difference and within the difference, and the ratio between the two give you the f value, and this is what the probability which you have fixed, and that too this is critical, and this is what the calculated, and since the f critical is overtaking the f calculated, as a result, so this is not actually statistically significant even at actually 10%, and these are actually the kind of summary statistics for this particular kind of problem. So, this is the actually the kind of output side for single factor model, and again you go to the spreadsheet, and then you allow the data analysis again. So, again you allow one ANOVA 2 factor models. So, it is extension again. So, in this case again you specify the range and allow that there are two, since 2 factors. So, you allow the 2 factor sampling, and then again put OK. So, this is how the analysis of actually a 2 factor kind of situations. So, you will find plenty of so that means you compare to the previous one. So, in the previous one, so you will find here plenty of results, and then finally, so you come to this final outcome, and here this is the sample, the factor A, and this is the factor B, and this is what the interactive A. That means, this is SSA, this is SSB, and this is SSAB, and then it is a kind of error component, and then this is mean sum squares of A, mean sum square of B, and this is the interactive mean sum square, and accordingly. So, these are all critical values, f critical values corresponding to a particular alpha levels, and this is actually f calculated, and compared to these criticals. So, we are not in a position to reject for the sample 1, that is the factor 1 case, and in the case of factor B also, it is also not in a position to reject, and again in the interactive. So, you are also not in a position to reject. So, that means, in this particular sample and problem, so we do not find any significant difference. In fact, the problem is actually this may be with respect to small sample case, because this is actually multiple sample case, means you must have actually more number of data points to validate this particular problems or the kind of issues, and then you can get some kind of better inference. So, likewise you can extend this particular model for 3 factor models, then you can go for completely 4 factor models, and then ANOVA, like the kind of situations, right. So, typically what I like to say that f is a kind of interesting factor through which you have to discuss the particular problem. And the last but not the least in this particular multi-sample case is the testing through chi-square observations, and in fact chi-square we have already discussed with the one sample case, and here we are dealing with the chi-square with the one sample case, and taking you to the clue actually for multiple sample case, and typically for categorical variables, because variable means informations may be numeric, but the variables may be kind of qualitative in nature. So, when a problem is having actually qualitative variables, and then how you have to dealing the situations, and then we will get the inference. So, chi-square is the best statistic through which you can actually analyze the particular situations. So, chi-square is a goodness of fit measures, and this is how the test structure through which actually you have to test the procedure. It is more or less same like Z test, T test and F test. In fact, chi-square one sample case we have already tested. So, it is actually sum total of the difference between observed frequency and expected frequency, and followed by the you will get the kind of calculated, and then followed by the kind of criticals, and then you will check whether there is a significant difference between observed frequency and the expected frequency. For examples, let us take an example like this. This is the milk sales data over the last 12 months of a year, and we like to check whether there is a significant difference about the samples with respect to sample means, right. So, the total of this cells is nothing but 18,447, and as a result these are all individual cells, and while doing the analysis. So, this is how the null hypothesis will specify, and then the type of the structure which you have fixed for testing. So, chi-square calculated is this much, and then we will see how is the kind of difference. So, the procedure of calculation is like this. So, now having the sample information this ones, and then what will you do? So, you have to calculate the kind of mean, and then the individual you have to find out the difference between the individual items with sample mean, and then with the help of this particular difference, squaring of the difference and followed by expected frequency, and once you have it this sum, that is what the actually chi-square total chi-square variance, and that need to be tested through criticals, and that the critical is here, and f critical is here coming actually 24.725 corresponding to alpha at actually 1%, and depending upon the degree of freedom, that is 11, that means the sample size is 12, and so the calculated value is coming 74.37. So, as a result we are in a position to reject. So, that means there is a significant difference between the individual items corresponding to sample a mean or mean of this particular series. So, likewise actually you can go for testing for population proportions, it is more or less same, and here the problem of population proportion will be like this. So, this is the observed frequency, then you have a expected frequency, and it is more or less same again. So, you have to find out the difference, and the squaring of the difference need to be tested again compared with the kind of a critical value, and on the basis of this data. So, we have actually calculated chi-square value is 19.64, and then again that need to be tested, and again which is actually in a position to reject. Okay, so, this is typically actually one sample case. These two problems are with respect to one sample case, but I like to highlight the concept with qualitative variables and the nominal data structure. And let me take you the problems. So, usually that is actually chi-square test for test of independence, and the examples will be let us say investment, and then find kind of how it is varying with respect to different locations. It is a kind of multiple sample case like two factor model which we have actually discussed. So, here all the similar kind of structures, and the same problems can be analyzed with chi-square test statistics. Let us have a look here. So, how is the kind of structure, sums are there, and if we add up all these column wise sums and row wise sums, then we will find actually combined samples, and then it will be tested. So, the typical idea actually like this, all right. So, this is actually the kind of structure, and then what do you like to do here? You have to find out the again the difference between the actual positions and the expected positions, and the expected position, that means actually in this case it is actually 3 into 4 matrix, and that means typically each entry is the kind of actual kind of observation or actual kind of facts, and then we will find out the expected fact, and the procedure to calculate the expected fact is like this. So, it is the actually row sum into column sums divided by the combined sum, and that is the expected point. So, that is why n I into n j means it is a ith columns, and that is the ith total, and n j means it is a jth column, and that to jth totals. So, that the multiplication of that two components divided by combined means will give you the position of that and that to expected frequency of that particular samples. Likewise, for every samples you can find out the expected frequency, and then finally, you have to find out the chi-square value, which is the difference between observed frequency and expected frequency, and that need to be again tested, and this is the sample problems, and that is with respect to income category and the type of gasoline, and there are 3 different types: regular, premium and extra premium, and then subject to income variations, there are 4 income variations, and this is how the types of gasoline is independent of income. That is the kind of problems which you need to investigate with these examples. And the corresponding alternative hypothesis is that the gasoline is not independent of income. So, accordingly the sample points are like this. So, corresponding to this income and types of gasoline, these are observed frequency, and accordingly with this some row sums and column sums for a particular positions, you have to find out the expected frequency, and then accordingly. So, this is how the procedure through which actually all the bracketed figures are actually the expected frequency, and then so you will find here for observed frequency there is expected frequency, and then you will find the difference, and that the square of the difference will be need to be tested, so whether they are statistically different and corresponding to expected frequency. And since it is actually variance statistics, so the procedures same procedure we are following in this particular case, and accordingly. So, after simplifications you are getting the total chi-square is equal to 70.78, and in the case of criticals, the critical value is showing here 16.812, and that too for degree of freedom 6, that is r minus 1 into c minus 1, and that is 3 minus 1 into 2 so that is coming actually 4 minus 1 into 3 minus 1, that is coming actually 6, and at 1% alpha level. So, you will find critical value is 16.818. So, here the calculated is 70.78 and the critical is 16.812. So, as a result, so what is happening? So, we are in a position to reject the true null hypothesis. So, that means the hypothesis which you have said here that the types of gasoline is independent of income. So, that means they have the kind of independency. So, since we are rejecting, so that means the conclusion will be, or the inference will be like that there is a kind of interdependency between this gasoline with subject to the income variations. So, likewise we have actually discussed couple of problems. So, in this particular unit, that is inferential analytics 2. So, we have actually solved some of the business problems relating to multiple sample case, and we have checked how is the kind of inference by using the t statistic, z statistic, chi-square statistic and f statistic, and typically the variation in the kind of analysis of variance, 1 factor model, 2 factor model, 3 factor models, and the kind of ANOVA. So, that means actually in a kind of real life scenario, or the kind of dynamic kind of business environment, you will find some of the problems can be investigated with multiple sample case, and the kind, and again you will find lots of interactive or interrelationship among these variables or the kind of samples, and the inferential analytics will give you the kind of exposures, how you have to understand these problems, and how you have to pick up a particular test statistic, and what is the kind of optimum sampling, or the kind of the kind of sample size which you can fix, and then how much, what is the kind of confidence interval we can build among these particular samples, and these are the things we are actually supposed to know from this particular inferential analytics 2, and that too. So, you have to see what are the business problems, and after knowing all these techniques and the kind of concept, the kind of connections. So, I am very sure this kind of problems can be investigated very nicely or easily, and then you can get some kind of inference as per the kind of business requirement. So, that means technically you may be in a position to come with some kind of management decision corresponding to a particular problems where we are dealing with a problem with multiple sample case. That means typically a multivariate situations, depending upon the kind of number of samples or number of variables, you can actually apply these techniques and then solve some kind of business problems. With this we will stop here, and thank you very much. Have a nice day.